Hello! Today in class we will solve some inequalities where we will use the distributive property. And the first inequality, 1/4 multiplied by 3 plus 8 times a is greater than 6.25 plus a. You often ask how to solve inequalities that involve fractional numbers. The method stays the same. Whatever numbers you come across, or inequalities can be represented in algebraic expressions. And then you use the same algorithm. Open the parentheses. Multiply 1/4 by 3 and 1/4 by 8a. What do we get? 1/4 multiplied by 3 plus 1/4 multiplied by 8a is greater than 6 and 25/100ths plus a. I want to note that on the left we have a fractional number, and on the right there is also a fractional number, but it is written as a decimal fraction. If possible, it's better to write a fractional number as a decimal. However, 1/4 times 3 equals 3/4, and 1/4 times 8 is 8 and 4, which I can divide by 4. This is 1 and 2. 3/4 plus 2a, greater than 6.25 added to a. I won't express 6.25 as a simple fraction. Why is that? The fact is, working with decimal fractions is simpler. I would rather convert it. 3/4 written as 0.75 plus 2a over 6.25 plus a. It's easier for me to use decimal notation here. This results in 2a minus a, more than 6.25 minus 0.75. If you prefer working with fractional numbers, you can express 6.25 as a fraction. Then apply the rules for working with fractions. 2a minus a equals a, which is greater than 6.25 minus 0.75. This equals 5.5. Now, let's write this result as an interval. To express this result as an interval, it's best to visualize the solution. To do this, we should draw a number line and mark the point at 5.5 and display the numbers that exceed 5.5. They are located to the right side, 5.5. Thus, all numbers are included, ranging from 5.5 to plus infinity. How do I note this answer? A is part of the segment from 5/10 to plus infinity. We recorded the answer of this inequality in 3 types. In the format of a numerical inequality and a numerical range, and a graphical method. One more example. 3/5 multiply, the bracket opens, 5, z minus 2/3 is larger than z. Let's consider greater than or equal to z, plus 7.6. We solve this inequality. We follow the same rules. Note that we are no longer solving the first inequality. And every time we use the same rule, we adhere to the procedure. We simplify the inequality step by step, transferring all variables to one side and keeping only numbers on the other. Let's multiply 3/5 by 5z minus 3/5. I multiply by 2/3. Note that in this case, I wrote the multiplication sign right away. I multiplied 3/5 by minus 2/3. I know that if I multiply a positive number by a negative one, the result is negative. So I wrote the sign right away. Greater than or equal to z plus 7.60. I can divide 5 by 5 now. 1 and 1. As a result, 3z minus remains. 3 plus 3. Dividing by 3 gives us 1, 1. The result is 2/5. Greater than or equal to z plus 7.60. And in this case, I saw a fractional number again, 2/5. We can write the number 2/5 as a decimal fraction. 3z minus 0.4. Z is greater than or equal to 7.60. Next, we find 3z minus z is greater than or equal to 7.60 plus 0.4. We just need to count now. 3z minus z is 2z, at least 8. It is evident that z is greater than or equal to 4. On the axis, we will draw a point at 4. I will show the interval. I will show the range in another way. We used an arrow. In past solutions, we illustrated the range on the coordinate axis. You can also use a line as well. In this case, I see that all numbers located to the right of 4 will solve our inequality. In the form of a numerical interval, I will write that z belongs to the range from 4 to infinity. Keep in mind that in the case of a non-strict inequality, meaning greater than or equal to, we represent it with a filled dot and a square bracket. However, we use round brackets for both plus and minus infinity. Next time, we will solve another inequality. For today, our lesson is finished. Goodbye.